Hello everybody. Let's see. Okie dokie. So, where did we leave off today? Yesterday. We wrote a little thing that lets us generate virtual machine code for the virtual machine we wrote. This is the virtual machine code for this source. So we push a 0, we store it in slot index 0, which is the variable a. Every variable gets a slot index within the function. The main program is its own special kind of function. We load it from there, push a 1, add a 1, and assign the result back to a. Now we also built a little debugger, which isn't the fanciest one, but it's good enough for this purpose. So this shows us what the next, this shows us what's on the stack, and this should show us what the next instruction is, but I think I fucked it up yesterday. So yeah, here you see the variable. This is essentially the call stack. So we assigned 0 to that. If I step again, then I loaded the slot, loaded the 0 into the stack. That's the load instruction. Then I pushed the value 1. Now I add that and the results on the stack. And now I write that into A. And the stack is empty. And if I step again, I get to the last instruction, which is the return, and I'm done. So yeah, this is not super amazing in terms of the debugger. And it would be very nice to have a better debugger. So I am now thinking about either today writing a foreign function interface that is a way for Paperbot scripts or Papyrus scripts to call into JavaScript, or to fix up the debugger and make it like a real thing where you can step over statements into functions, inspect variables, and so on and so forth. For that, we need to annotate the virtual machine code with some data next to the code array, which consists of instructions. We also need an array that tells us where the statement boundaries are. Now there's a difference between a line and a statement, because a statement can also be this. So it's not enough to just step over source lines. I need to actually say these two lines are actually a single statement in the virtual machine code. In the source code, it's of course not a single statement. So I have to annotate that somehow, but I'm not sure I'm in the mood for that today because I'm a little sick still, and it's a bit complicated. So the alternative to that is to write a foreign function interface that allows me to call JavaScript functions from within Paperbots. And for that I need to clean up a bunch of things. And I think I'm gonna do that first because that's more useful. If I fail to write the debugger with stepping until Friday, when I need to use this in class, it's not too big of a deal. When I fail to be able to call foreign functions, that would be bad. Because then I cannot do this in the code, because these are JavaScript functions. So let's quickly discuss what we need for the foreign function interface. When a program is being compiled, what it does is it runs through the source code, collects all the functions first, and the main function, which is any statement outside of a function, gets collected into a big array of statements. Everything is an AST node at this point. So I would like to clean that up and actually generate a function declaration AST node for this list of statements for the main function, so things are a little cleaner. Then the second thing is, if I want to invoke a function provided by the runtime, like forward, which moves the robot forward by a cell, that needs to be injected into the compiler. think of it as including a linking to a third-party library that only has the declarations for the code. So we need to have a mechanism for that. That shouldn't be too hard for functions. If you want to inject external types, that's going to be harder. But I think I'm going to postpone types and just allow foreign functions to be called with types that are defined within your program. That's a lot easier. And then there's the distinction between asynchronous functions, foreign functions, like the forward is an asynchronous function, because when this gets executed, the virtual machine needs to be paused and wait for the action that's being executed here, this little move for 0.5 seconds across the screen. The virtual machine needs to wait until that is done. So foreign functions need to signify whether they are blocking or non-blocking. Like a blocking one could be a foreign function like alert. Or another one could be something that converts a number to a string. That's just the standard library. So we need the foreign functions not only for these little robot things, but also to inject the implementation of standard library functions. Think of that like JNI functions in Java, for example, or CPython stuff. Okay, so I guess we're going to do that. And the first thing we're going to do is we're going to clean our act up a little bit and create a function declaration for the main program. So let's write a real simple main program. Okay, and we want all of this to become its own function with an AST node, an artificial one that stores the information that we usually have for a function declaration. Okay, so let me close all the non-useful things. And then let's open up the compiler. Good. The artificial AST node we need to generate for the main function will be a function declaration, because that's what we get for any other function. So if I define a function foo, nothing, then I get an AST node here. Sorry, this is the AST node for, yeah, I should do this in the playground. It's a little more obvious here. So this is the first function. Yeah, this is the function foo. So what we want to generate is this AST here. If I put a little thingamajig in here, I get the statements of the function. And what I want to do is I want to generate this kind of AST node and inject, oh, we're at the top of the thing. I want to generate that AST node and inject all the main program statements inside this block. The location of that function, so let's see if we have all the data that we need for the main function that we are artificially going to generate. The kind is a function, that's easy. The name, there won't be a location for the name, so we can just insert some bogus values here. The important part is the Is this a good idea? Yeah, this is a good idea. The main function will not have a parameter, and the return type will be nothing. The block will consist of AST nodes for the individual statements of that main function. The location of the function will be the entire program, and the return type will be nothing, which is like void. Okay, let's see. So in the compile function, what I do is I parse the entire program into an AST, then I filter by AST kind, so I get out the functions, I get out the record definitions, which would be something like this. For Friday I ignore records, I also ignore strings. We're gonna use booleans and numbers only, so no records, no strings, no lists, which would be the data types that would also be available later on. So anyways, I pull out the functions and I pull out the records, and any other ASTs on the top level, AST nodes on the top level essentially make up the main program. So here I say main program, let's fix it up to main program statements, or let's say main statements. Then I create a main function, and I can do this like so. The kind will be function. What else do we need in here? We need the block. The block is an array of statements, if I remember correctly. So the main statements should do just fine. I might have to. The parameters is an array. In this case, it's an empty array, so it'll be fine. The return type is the built-in nothing type. Up. And the return type name can be null, because we will never need this. So the last thing we need to store here is the location, and that is an I file thingamajig. So if start equals the column 0. Oh, yeah, no, that's stupid. So the line is 1 and the column is 0, and then there's an offset which is also 0. This is an interface, a struct that comes from pack.js, the parser generator I'm using. Start end. So the end is the last line in the program, which should probably be, yeah, I don't know. We should probably be smarter about this. Okay, let's just start out with some random values. This is gonna bite me in the butt later on, but it's not too bad. Why does it complain? A main function is killed, but its value is never read, and that's okay. So what we're gonna do is we're gonna append this to the functions array. Push the main function. Okay. Now could you stop complaining, TypeScript? Oh, that's not nice. Program name is missing in type kind. Okay, that makes sense. So the name is value, and a location again. So I'm gonna reuse this location. What a mess. Value is, and we will use a special name called main. Okay, so what we did here is now construct an artificial AST node for the main function, which is all the statements outside of real user-defined functions. And then we can actually get rid of this main program stuff here, because everything will be in the functions array. So let's fix this up. Okay, let's see where it complains. Okay, that's fine. That seems to do what we need to do, because we are now just iterating over all the functions of the program, the AST nodes for that, and pass them to the type checking function, which will make sure that all the statements in there are properly type checked and have assigned types. So that should be good. And then we have the init program thing, which takes the main program and the functions. This now has changed. Yeah, I can. Okay, so I'm just passing in the functions now. We should make the main function the first function in the functions array, so we push it in onto the front of that functions list. Where is it? God damn it. Yeah, and compile. There we are. Okay, so here, how do you add an element in front of an array in JavaScript? JavaScript add element in front of an array. Unshift. Add new items to the beginning. This is a really cool name for adding something in front of the. Okay. So with this in the code emitter, we are now just walking over all the function declarations, which includes the main function in position 1, position 0. This should all be good. Okay. The virtual machine, when it gets the emitted code, receives an array of function codes, which is a stupid name which you have to fix. And those contain. Okay, I can get rid of this because now all I have is function declarations. I can find all the references and make sure that I don't. Yeah, I don't need to do this anymore. So let's go here. Perfect. I like this. Fun's not. What am I doing here? Why am I only doing this for? Ah yeah, I need to add all the parameter. Yeah, what I'm doing here is I create the local variables for a function in the emitted code. That is the assignment of the variables to slots in a frame within the code. I don't need to special case this for the main function anymore, so that is fine. Function decal. Okay, that's cool. Now I totally forgot what I was special casing. I was special casing. I was special casing this function code thing. Yeah, this here. Let's see where else we're using this, because previously it was either the array of statements of the main function or a functional declaration. Now everything's a function declaration. So this says function calls may leave a value on the stack if they return a value. Function signature. Okay, this looks good to me. This looks good to me, and this looks good to me, and this seems to be the only places where we did a thing. Okay, then we just need to fix this up because we no longer need to cast here. Great. So let's just look at the diff to make sure that we didn't screw anything up. Oh, there's a bunch of nodes running. That's not good. Okay. I was wondering why the port was 8002. So let's go to a test. Wow, that still works. I'm so amazed. Does it do the right thing though? Yeah, it creates an AST for the main function. Great, that's exactly what we wanted. It assigns 0 parameters, the return type is nothing, the return type name. We could be nice about this and actually also, now let's screw this. No return type name was given, that's fine. And the location we need to fix up later on. Not too bad. Okay, what we wanted to do was to look at the diff to see if I fucked something up. Okay, this is just creating this artificial AST node. This is cleaning up the main thing. The scopes should work as intended. Emit program, yep, and that's it. Okay. Come on. Here we're good. Okay, so refactoring complete. So now everything's a function, including the statements of the main program. Let's see if this still works. Okay. So we pushed the null, we restored it, we load a null, we push. We push the value 10, and then we multiply it. It's still null. We store it in A. We push the value 3. We store it in B. We load B, and we loaded A. We added them, and we store it back to B. So looks good. Cool. This is still working. And now let's try the same here. A a number, B a number, and return A plus B. This is not good. Oh yeah, it returns nothing. That's not gonna work. Okay. So step, we push a 2, we push it into the slot. We push a 3, we store it into the slot. We loaded A, we loaded B onto the stack, and now we can call the function. There we have, oh, we are back in. Yeah, that's not cool. I need to make this debugger better. This virtual machine debugger, which is on an instruction level, this is just really terrible. So yeah, let's do that real quick. Otherwise I'm gonna waste a lot of time debugging something with a broken debugger. This is not the debugger that the kids will see, but for me it's nice to have that. Cannot read property locals of undefined. Well, that's a good hint of what's going on. Okay, let's enable this, and then let's rerun our thingamajig. Okay, so where are we? We are in the call. The function index is 2. And that's not good because we only have 0 and 1 here. So when we assigned indices to each of the functions, there is something that's going wrong. So let's see, this is in init program. Functions length. This should be function codes length. Perfect, now we're in foo, so things work again. So as you can see, this is the fancy pants call stack. We are in main at some function, at some instruction, the call instruction actually. And we are now in foo with those two parameters set to the values that we pushed in a step. So if I step now, we load those two parameters onto the stack, and then we add them, and then we return them by keeping them on the stack. And in the main function where we're back now, we just pop that because it's not being consumed, and we're done. Cool. Thing still works. It would still be nice to have a better kind of low-level debugger. So let's quickly write that. I'm just going to make the output of this a little bit more sane. That is, I'm going to print the contents of the local variables. I'm going to print a call stack from top to bottom. For each frame, I'm going to print the contents of the local variables. I'm going to print the instruction that I'm currently at, that's going to be executed when I click step. And I'm going to actually print the entire instruction, all the instructions for that function with a little thing indicating where I'm at. And I keep printing the stack values here for expression evaluation. So where was this? This was in this was in Paperbots, if I'm not mistaken. Yes, this is the debugger. So what the debugger does, let's clean up this mess here first. So if I click run, it takes the source code, recompiles it, and then it should enable this button. So this button by default should be not enabled. So let's fix this up and just make it pretty so I don't confuse myself. So this is pb debug run. Okay. Where did my Paperbots go? Yeah, yesterday, Eric Curry. Oh, you're doing Paperbots. Yes, I'm coding up the language that I'm going to use together with you to teach you programming. So what I'm building here is a programming language. Everybody say hi to Erica. She's on the Spine esoteric software team doing stuff for them. And I'm teaching her how to program. Yay! The things I do. That's the reason why there's no lecture this week for you and the rest of the guys. Okay, so yesterday I got Michael Bain, Sam Skivert, a good friend of mine who is an inspiration and a mentor, came on a stream and told me I'm stupid for not using React. He's absolutely right. I'm using jQuery here, and I'm just using TypeScript to componentize my front end. It's terrible, but I can't be asked to learn React. I need to get this done by Friday, so I'm just gonna cobble together this little thing. This debugger class is responsible for the elements down here, which consists of these buttons, this output pane and this output pane. If I click on that button, what do I want to do? I want to enable this one. Okay, so what I'm gonna do, if I click on run, I want this to say stop, and I want this button to be enabled, and if this is stop and I click on it, then I want it to switch back to run, clear out the virtual machine, and disable the rest of the buttons. So I'm gonna do that real quick and dirty, because I'm not gonna manage the state. Oh yeah, I'm gonna manage the state like this because I'm a terrible human being. VM is a field which can be null, so I'm using this as my state indicator. Fuck it. So if this is not, this is null, I know I'm not running. If it is not null, I know I'm not running, so I'm gonna clear this out. Clear out the call stack and the value stack, which is the yellow and the green pane. And I disable debug step attributes disabled true. I think that's how it works. In this case, I want it to be not disabled. This should be good. Let's see if this works. So I click, oh yeah, and I also want the debug run button to say stop and not run. All hail jQuery. It's the best of the worst. So, hello. So I click on this, it says, oh no, I click on this, it says stop, and this is still not disabled, still disabled. If I click on it, it's run again. So this works, this doesn't work. Is it attribute? jQuery. Oh, I've searched for this before. Fantastic. Attribute disabled, true. Remove attribute. Okay. Remove attribute disabled. And set attribute. Let's see if this works. Yes, my pretties. Okay. Stop. And we're done. Goodie. Now we need to fix up this this terrible thing here, which is my current debugger output thingamajig. I'm gonna write that in a function. So render VM state, and we get the VM, and we pretend I'm gonna fetch me the HTML elements here, call stack and the value stack. Okay, and then we can see what we can keep from this. So all of this is terrible. We also don't want to do this. Okay. So if steps clicked, I want to run the VM for one step. So I execute the next instruction, and then I want to render the VM state. But I also want to render that in when I start the thingamajig. Why doesn't it know virtual machine? Because it's a module symbol, so I have to import that. And what am I doing here? If the VM frames is bigger than I blah blah. Okay. Yeah, we're gonna just ignore all of this because fuck that. Okay, we need the call stack output. Okay, looking good so far. If we click on run, things should explode. Do they explode? I'm not sure if this is the correct imaging. Okay. Okay. Call stack inner HTML equals output. And that's what we want to do at the end of running through the VM state and creating one big ass freaking string out of it. And we want to do the same here. So the value stack in HTML is going to be the output again, and the output is going to be nothing in this case. Blah, 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 blah. So if I click run, it should show me what's up. Yep, that's good. Okay. Cool. So this works. Let's fix up the font of these two things. They should be monospaced, I think. So that's the call stack. So font family is monospace. It should be good enough. Yeah, that's a little better, I guess. Yeah, I can live with that. Okay, cool. Then for each function, I want to output and you see I'm doing really bad things here, but it doesn't matter. Okay, this is nicer. Oh, there's a lot more people in here now. Nivrig, I know that name. Commander Root, BitOiler, I know. Erica, I know. The rest I don't know. Stockholm, Sweden, sounds good. Also, if you have any questions, it doesn't have to concern the thing I'm working on, just post them in the chat and I shall answer. So, we have printed all the things here, and the next thing we're gonna do is, what do we not know? I missed a bit. Hello, Chronosella. No, the question from my end was if you have any questions concerning anything really, well, as long as it's related to something like programming, just post them in the chat and I'll try to answer. I can also give political opinions, but you don't want to hear those, I think. So the next thing, since we can now see the call stack like this, is to output the instructions of the functions that we're currently in and point at the one that's going to be executed next. Yeah, let's do that. The first thing that's really bad is that there's a code thing kind of going on here. So I have the code, which is the function code, which is the compiled version of a function, and that itself has code, which is freaking not good. So we're gonna rename this to instructions because that's what it actually is. Let's see if this still works. Step to work. Okay, so now we're gonna, what we have, I'm here to hear your hate rants. It's not a day if you're not hating a programming language at some point. Oh, I hate all the programming languages equally. I'm an egalitarian when it comes to that. So what I'm gonna do now is maybe some explanation. When the VM runs, there's a bunch of frames for each call we are in. So the call stack, so to speak. What I'm doing here is I go through those frames from the top of that call stack to the bottom. Yes, most of, I hate my own programming language the most. It's the worst for now. Anyway, so I'm going through all this, I'm going through the call stack and printing the call stack from top to bottom in this yellow pane. This is what I'm gonna do. Here we output the name of the function, although this is not necessary. I can just do this because now we have a function declaration for the main function. Perfect. I print the function name and its signature. Yeah, Minimoog. It's okay to hate your own stuff. Keeps you going, improving it. So I print a signature, then I print each variable inside of that frame. I'm currently printing all the ones that are defined in the function, even though they might not be in scope yet. You will see that those are null. Yes, yellow pane, green pane, gray pane, we got all the panes. Welcome to the pane emporium. So we got the function signature for the frame, we got the variable and their variable, the variables and the values for the frame, and now we also want to do the machine code, the virtual machine code, and a pointer to where which machine code is currently is the next one we're going to step over. So I need to fetch from the frame the code dot instructions, and for each of these I'm gonna add more bullshit to my string. So output plus JSON.stringify because I'm a cheap motherfucker, plus a break, a line break, And then we also need to point at the thing that's going to be the next instruction. So let PC equal frame.code frame.pc. If PC equals if you're at the end of our function, that is the last statement in there, we should probably not try to draw a pointer for that function. Yeah. So if we're, this is a special case, if we are going to execute the last instruction, next PC is the current PC plus 1. If that next PC, the program counter, equals the length of the instructions array of the function that we're currently inside of in the call stack, then I need to do something special. Then I need, yes, okay. Yeah, my brain is mush today, so I might not get a lot done, but I think I can get this done and the foreign function interfaces for blocking and non-blocking function calls, and then I call it a day. So should be another hour or so. It's probably going to be 5 hours, but fuck it. Also, I'm going to take a break at 7 o'clock for 10 minutes, and you guys have to come back later on, so I can keep babbling at you. Anyways, where was I? I figure out the next PC. If the next PC tells me that it's actually an instruction outside of the instructions array of that function, the important things, but what are your semicolon rules in JavaScript? This is not JavaScript, this is TypeScript. My semicolon rules are, I place them at the end of the statement unless I forget, because I'm working in so many different languages with and without semicolons that my muscle memory is all kinds of fucked up. Ideally, I would place semicolons just to be explicit. I like explicitness. What the crap am I doing? Oh yeah. Note here Slint. No, because I am not informed about the latest and greatest in the web stack. I got the compiler running, and that tells me most of my bullshit. So yeah, I got 2 errors in there at the moment, which I ignore, and I'm pretty sure TSLint would tell me even more stupid errors I'm doing. Also, it seems the TypeScript compiler has a bunch of bugs. We ran into that in the last stream, which is fun. The type inference doesn't work, so I wouldn't trust TSLint either. So yeah. Also, this is a private project, so make of that what you want. Kronos Sala, do I know you from somewhere? You seem well informed. What am I doing here? Okay, let's just... Okay, I'm not gonna for each this actually, because I need to keep track of the index. Does anybody know if for each can give me the index as well as the element? So that takes a callback. Oh, I can get the index. That's freaking amazing. Oh no. He's from your uni, apparently met at Game Dev Days. Yeah, I don't know who he is. Send pictures. No nudes, just the face, so I know who you are. At the JV Music Group talk. Ah, that kind of reduces the number of people it could be to about 3. That's how many people were there at the last talk. Yeah, still don't know who you are. So it's a mystery, really. Okay, we don't need this actually. So I'm checking if the next PC is the current instruction I'm putting out there. So I'm just gonna JSON stringify the instruction because they are nice enough as is. And if the index equals the next PC, then I want to highlight this instruction. Otherwise, I'm gonna 1, 2, 3, 4, 1, not highlighted. And this is how we do debugging output in the ghetto. Just create a big fat string and push it into the freaking div. Hello! And this did not what I wanted to do. So why the hell is my... yeah, if you're gonna be dumb, you gotta be tough. Nice. Not exactly what I wanted, but let's see. Well, actually, why am I doing this? This looks correct. So why are my white spaces ignored here? This is very interesting. I guess I have to output spans. Now that's a lot of fun. Why just output code? It doesn't matter. Again, welcome to Ghetto Programming 101. Well, Ghetto HTML, CSS programming, that is. Yep, doesn't work either. Fuck it. Okay, we're gonna fix this later. I just need to see if the step works. Yes. Push 3 on the stack. Push. Yep. 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 Ha. Perfect. Everybody saw that? Hooray! I still want to get this stupid little thing working, so just put the whole thing in pre-block or add the corresponding CSS rule, how it's called. Yeah, I don't know what the rule is. That's, everything's terrible. I guess I can just ignore this and ignore this. Let's make the div a pre. And I'm sure this is not going to work as I want it to work. But oh, wonderful. Everything is terrible, but at least my white space is now interpreted correctly. And we're gonna figure out, oh my god. I'm working on a Windows keyboard on macOS. This is not good. Why is there this thing? I'm sure the pre has a margin. Yes, of course it has a margin, because why the fuck not? A margin as a default is always a good thing, right? I cannot tell you how much I hate CSS. Yeah. Well, might as well use it. Oh, fuck it. And we changed it back to our div. So I feel it coming. Yeah, CSS is terrible. Oh my fucking shit! Look at this. It's perfect. Okay, great, fantastic. Oh my god, look at it. It's beautiful. Now I also want to visualize the call stack over here. So let's do that real quick. It's not the call stack, it's the value stack. So that should be easier. We're gonna copy a floppy. So the stack is part of the virtual machine, so this should be a lot easier. We want to traverse it from top to bottom, I guess. So we can do the same thing as above. Stack dot slice 0 reverse for each. Yes, I could write this. Yeah, it looks beautiful, right? So output plus equals JSON.stringify value is this all we need? Okay. Run. Hooray! Perfect. Cool. Let's make it a little prettier because it looks kind of like giving you an aneurysm. So this I like, but I would probably want to have like a little separation here. The instructions. And then I'm gonna say, hey, oh my god. Locals, instructions. Okay, here we want to say that this is the stack. And we want to output the index as well. So we're going to do it like this. Yeah, I could have put that all in a chain 1, 2, 3. Okie dokie. Look at it, it's beautiful. Let's change the color of this and call it a day. So we're gonna make this okay, colors. Who wants cool colors? I need cool colors. What could be a good color for this? Actually, why don't I keep the green background and just make the foreground color white, because why the frick not? Run. Perfect step. Wonderful. Let's do it one more time. Push it to, store it in A. Oh, yeah, that's something I could do. For the locals. First of all, we can there's a lot of people in the chat. I am very surprised. Hello, you all. Goody. Ah, that looks so much better. We're gonna fix this up as well. And one more time. Wonderful. So now here you see the slot index for the variable. Here you see the variable name and you see its current value. If they are not within scope yet, they haven't been assigned yet, so they have the value null. We can later, with the debugging information, we can figure out the life time of a variable and only show things that are actually in scope at the moment. We'll have to try to push you to all the money. Oh yeah, please push me to all the money. It's very important. Okay, so we push that, we store it, we push that, we store it, we load that, a reload 1, the slot index 1, and we call the function. And when we call the function, those two top of the stack arguments get popped and loaded into the locals for the parameters a and b of the function foo. And then we step through the rest of the function. So we load slot 1, we load slot 2, we add them, and we return them, which means it stays, the return value stays on the stack. Back in our main function, we take what's on the stack and store it in slot index 1, so in B, and we are done. Amazing. You just watched the first beautiful run of the Paperbots virtual machine. So it's 7 o'clock. That means I've streamed for an hour now. I'm happy with this preliminary result. Fixed low-level debugger. Do you have nicer output? Main statements of main function are now pushed into an artificial function decal, unifying the handling of the entire program. Wonderful. Are you going to do a live variable analysis and explain me everything lattices? Oh, Nate is here. Hello, Nate. He's another spine person. Everybody say hello. Are you going to stream RL too? No, I'm not going to play RL and I'm not going to stream gaming because I'm bad at it. That means worse than at programming. But I'm super good at taking a break. And that's what I'm gonna do now, so I'll be back in about 10 minutes. I'll be back at 19:10, 7:10 p.m. CEST. Let's make this real freaking big so everybody can see it when they hop on the stream. And then we also need this. Oh, actually, what I'm gonna do is I save this image on my desktop and then wait for it. I'm gonna add an image. Okie dokie. Gonna browse. Where's my desktop? Perfect. Do you all see the wonderful image now? And to keep people interested, I'm gonna leave this here. No countdown overlay. No, I'm not that advanced. I suck at streaming just as much as I suck at programming. But I leave you with an Arnold, so I'll be back. And we are back. Hello, my pretties. Oh no. Oh, that's interesting. I wonder what this key combination does. I hope it deleted all my changes. Running during breaks that we can all together control by sparing the command in chat. Yeah, that would be fun. Let me catch up on the chat, okay? So yeah, no countdown overlay because I am suck. No countdown overlay. Power. High value stream overlay. Yes, it is a high value stream overlay. What kind of I'll be back was that? That was the I am back at 7:15 when I was supposed to come back at 7:10. No waiting ring music. Nope. Search for the terminated theme. Yeah, next time. So Twitch can block my channel. I'm sure Erika could do some amazing spine magic and animate a cartoon version of Bad Logic games hammering and raging in front of a computer or stack. Yeah, that would be fun. I think there's something like hand over the stream to someone else. I'm down with the chat command Paperbot. Just you guys write a bot thing and I wire it up with some backend web scale, MongoDB. Cool stuff. Anyways, so what we're gonna do now is build something that lets us call JavaScript functions from Paperbots. There are two types of JavaScript functions we want to invoke. One is asynchronous, that is the interpreter needs to know that if it calls that function, it should wait until the function says, I'm done, here's the result. And the other one is non-blocking. We need to inject those functions at two places. Once when we compile the source code, because it needs to know, the compiler needs to know the function specification or declaration. So I could have JS underline alert that takes a string and returns nothing, and the compiler needs to know that this exists, even though it doesn't know what code's behind it. The compiler does not have to know at this point if this function is blocking or non-blocking. It just needs the signature. So let's start by doing that. Let's see. This is only really necessary when we are trying to access a function. That is when we try to call a function. So in the type checker, let's see what the type checker does when it calls a function, or when it processes a function call. So let's see. JS alert, and that takes a string. Okay, cannot find function JS alert string, and we need to figure out where in the type checker this is actually being done. This is not really part of a type checker. This is more part of a semantic analysis phase of a compiler. But I am a bad programmer, so I put it in the type checking. What the type checker does, it goes through all the nodes, the AST nodes. For those of you who haven't seen the previous streams, what's an AST node? I have this code. It gets translated into a tree. This is an expression, an arithmetic expression consisting of a binary operator which requires two arguments on the left and the right side. Oh, I didn't remove the I'll be back image, yeah. Thank you. Yes. Okay. I should probably create a scene for that. I will do that some other day. Anyways. So the AST is just a tree representation of my program where different parts of the program correspond to an AST, an abstract syntax tree node type. The binary operator multiply boils down to a binary op AST tree, which encodes the operator. It represents the multiplication. It has an expression to the left and an expression to the right, and that is recursive. So you can have a much bigger tree down here. For example, I could have this 2 + 2 becomes its own tree, so to speak. And it's the left-hand side of this binary operator. So this is the outer operator. This is the left-hand expression, which again is a binary operator node with a left side, which is a number literal, and the right side. So that's the basic thing. And the type checker goes through all the ASTs for all the functions in my program and assigns types and then bubbles them up. So it goes depth first down the tree. If it finds something like this, a literal, like the number 2, it can immediately assign a type, in this case number. The binary operation also has a type, which is number, and so on and so forth. And you bubble that information up the tree, and at each node, you check if the constituents of that node have the correct types. And if not, you throw a type error, and if they don't have the correct types, you throw a type error, and if they have the correct types, you're happy and just keep processing the tree. For example, the binary op AST first recursively assigns and type checks the left and right side expressions of that binary operation. And once that's done, based on the operator type, it checks if the left expression has a number type and the right expression has a number type for the arithmetic operators. If that's not the case, it just craps itself and spits out a type error. Otherwise, the node itself gets the number type, and so on and so forth. So this is very basic type checking for function calls. So if we have something like JS alert string, the type checker needs to find that function, then evaluate the types of each argument. And since my language allows overloading of functions based on parameter types and number of parameters, it's a little bit more involved than your run-of-the-mill kind of function call checking. So there is an AST node called function call. And what that does is, for each argument, in this case we only have one, this expression, it calls the type checking recursively. Which means that this expression gets a type assigned. Since it's a string literal, the type of that will be string. Once we're done assigning all the types to all the argument expressions, we can then take the name and the types of each argument and construct a signature and look that up in a lookup of all the functions that have been defined in the program. So that's what's happening here. I construct the function signature from this node. Well, actually, let me entertain you and just debug compilation of this funky little program. So there's the compiler, type check rec. Okay. Goody good, good. Let's trigger the compiler. So now we are actually type checking the AST node for this function call. And as I said, it has arguments. The argument currently is an AST node that is a string literal, and it currently doesn't have a type assigned to it yet. If I step and check that AST node again, I get a type, and that type is a built-in type because that means it has no declaration node. It wasn't a user-defined type, so I assign just the name of the built-in type string. That's fine. And then we also have the value of the literal, which is str. Okay, cool. So now that I know the types of the arguments and the name, I can look up that thing with a unique key, and that's its signature. So let's see what the signature actually looks like. The signature of that function call is JS alert, the name, plus the types of each of the expressions for the arguments. Awesome. So then it goes into types, which is just a catch-all kind of structure, which has a lookup for functions by signature. And currently in that thing, we only have the main function, because that's the only function we have in our program. So to inject an external function into the compiler for semantic analysis purposes, we just need to add function signatures into this little thing. Then the compiler is happy because it can find those function signatures and the function declarations that go along with it. So let's see how we can best do this. Continue. Okay. So this is the main entry point for the compiler. And here we will create an interface called external function. And that external function consists of, what does it consist of? It consists of the name of the function. It consists of the argument types, which is an array of type. Type is a class or interface of the compiler. And then it has a return type, which again is a type, and this should be it. And my compiler thingamajig needs to get an array of external functions. Actually, I believe I should make this a string, the names of the types, which will represent the signature of that type. Because say I create a record in Paperbots, something like this. X number, Y number, and okay. So then the compiler will create a type for this user-defined type, which has the name point. Okay. When I have a JavaScript function that should take a point, I'm a little bit at an impasse here when I pass in the external function that should process this. So let's say I have a JavaScript function, I don't know, do stuff with point, which has a signature like this. It takes a point and it returns a point. If I want to push that into the compile phase with this kind of definition of external function, then I already need to know the type before the type has actually been constructed by the compiler. So it sort of kind of makes sense to not do that and instead have the external user specify external functions as strings. So they would just say point or number or string or array, it doesn't matter, because those are signatures of the types. And the compiler then, let's make it that, return type name. And then we have archetypes, which is an array of type. And return type, which is the actual type. So the user provides these three, and the compiler then looks up the types based on their signature or name and assigns them to those internal things. So in order to make this even a little less fucky, we can make this a thing. So I'm creating a class here just so that there's default initialization of this and that nobody can fuck up creating an external function. Okay, this is a new array of type. And this is a null at this point because we don't know yet what it is. What? Okay. This should then be okay. Everything's terrible. Doesn't matter. So I'm getting the external functions here now. Let's inject this JS alert thing in our chest driver here. So I'm gonna open up. No, I don't want to print the thing. Printing is so 2002. Test.html. Is that what I want? What I really want? No. What I really want is Paperbots. There is a compile function in the editor, and that compile function takes, yeah, this is where we call the compile function. So in the compile function of the editor, I'm gonna create a bunch of externals which is a new array of external function. Okay, and into those externals, I now push my external functions. So I create a new external function, which has the name JSAlert, which has argument type names. In this case, it only has, let's say, a string. And it has a return type, which is the type nothing. And the rest is default values that the compiler then creates. We can also do a JS prompt, which takes a string for the default message and returns a string. Wonderful. Wonderful, wonderful, wonderful. Okay, so then my compile function gets that external function array and should now be able to look that up, and that's what we're going to implement now. Okay, we start in the type checker. We need to bubble those external functions down, well, not bubble, but push them down into our type checking. So functions, records, and we're going to have external functions here. Is that a good idea? Yes, it is a good idea. So the type checker gets the external function array of external function here. So the type checker starts by building up this type structure, which is the all-encompassing and all-knowing type container. It would probably make sense to push these external functions into this types container. So I'm gonna extend that with external functions, which is a map of a string to an external function. Okie dokie. Now we should get a complaint here. Yes, wonderful. External functions. And we're gonna assign, yeah, this should be called differently. Why do you complain? It's not assignable to map external function. Ah, yeah, that's correct. Okay. So what we want external functions to be is a lookup again, where the function signature is the key and the external function is the value, if the lookup is correct. But hell yeah, should is cool. Yeah, the idea is cool. Okay, so what does the type checker in the beginning? It sets up the built-in types. Then for each function, it creates a function type, so to speak, and puts it in the all-encompassing types map and in the specific functions map. This should actually not be necessary, but well, let's just keep it for now. Then I gather all the records, the record definition in my program. So after these two things, I know all the functions that exist and I know all the records that exist. What I have to do is here, when I add functions from the program into the types, I need to check if any external function has the same name or same signature. So we're gonna do this here. For all the external functions, for each other. Okay. Then I need a new signature, function signature thing. So the function signature either takes a function declaration or a function call, or in this case, an external function. And then we have to cover that case. External. What? Ah. Yeah, the external function has no kind. It's kind of sad. Well, this is bad. Just tells me that my design is a little fucked up. See if this works. Oh, of course that doesn't work. What does it? Turn fun dot. What's fun at this point? Okay, we're not going to do it like that. It would have been nice to have one single function that creates function signatures, but it's too much of a pain to get that into the union. So this will have a private field, private signature, or actually it's a public read-only field. Public read-only signature is a string, and we're gonna create the signature of that function in here. Also, it would be nice if we called it signature and not signature. So we're gonna copy the floppy. Type name. Yeah, this is wonky code formatting, but at this point I don't care. Because we need to get the shizzle done. Arc type names, we map those. The arc is just a string, so I can just actually say join with this and then this. Cool, signature equals cool. So now the signature is contained in the external function and built up from the user specified types and function name. So we can go back into when we gather all the functions and check if there's already a function that's been called that. Like, for example, I could have a fun foo, which takes a, which is a number, and if I define another num foo with the same signature, is already defined in line 1. So yeah, this is what's happening here. If I overload this, then everything's fine again. But now we also need to make sure that no external function can be called. No external function has the same name and signature. So we gonna, what was that defined as? I think as a string. Okay, so far we don't check for that yet, but that's what we're gonna do here now, because in our Paperbots we checked a couple of defaults. JS alert with a string and then nothing is returned. It's the same signature as this user-defined one, and we should prevent the user from overriding those functions. So that would be nice. So what we do here, we push the external functions into the type checker. When it collects all the functions, it checks if there is an external function with the same signature. So I can check if the type name for that function, which is the signature, equals the external other function's signature. Then I throw a new compiler error and say function fun other dot name already defined externally. Okay, cool. And for error reporting, I need to give it the location of what I want to highlight. So in this case, the function that has already been defined, I want to highlight that. So, and if I reload this now, then we get our type checked fuckery. Function JS alert already defined externally. Wonderful. So this works. We can check it with another function. I think the prompt function. And that takes a string, is already defined externally. Okay, cool. So this part works. Now I need to push the external functions into my types, and what I need to do is, if you remember the definition of external function, the definition of external function has user-provided things, but it also has things that the compiler needs to inject once we know all the types. So let's do that as well. If we know all the functions and we know all the records, we know all the types, because any new types the user can specify can only be records. If my function signature of the external function needs one of these record types that the user defined, we can only inject it after we know about that. So this works here. So the return type is not part of the function. No, it's not. Return type signature, overloading on return type is really hard. That's why the return type is not part of the function signature. I give you an example. If I have a fun foo, which takes nothing and returns a string, and I have a fun foo, which takes nothing and returns returns a number, for us as the humans, it makes sense that this is a different thing. But now if you support this kind of variable initialization, we cannot decide which of the two to call, because the type of A depends on the type of the returned value of foo. So I have two ways of solving this. Either I say, nope, can't overload on the return type. Or I say, in a case like this, where the type of some part of the expression is derived from another part of the expression, like the function here, I can say, okay, you have to be explicit about your types. So I could say number, and then I have enough information again to pick the correct foo based on the return type. But I think this is not a good idea. I don't want to get into the territory. And overloading only by arguments is a lot nicer. So now I know can't assign a value of type string to variable A, so that makes sense. So I can either change that down. I like that my type checker is so small and so good. Yeah, does this answer your question? Return type signatures, signatures based on return types is not really super useful. At least not in the context of this language. So what we were about to do is, if the external function references a type that is, if the external, I need to resolve all the real types, like the type class instances for the type names that the external function specifies on construction. So we're gonna go through all the external functions here. Fun. And then for each, let's start with the return type. That's actually easier. Fun.return type name. If no return type name was given, then I assume the nothing type. So the fun return type name becomes nothing, and the fun.return type becomes the built-in nothing type. The built-in nothing type is declared here as a constant. The same is true for numbers, strings, and booleans. Okie dokie, I lost the position in my... Does anybody know in Visual Studio Code what the key code or the hotkey is for going back to the last cursor position? That would be really helpful. So that's the first case for the return type when the name wasn't given. Else, when it was given, I need to look it up in my types. All fun.return type name. Let's return type equal blah blah. And if that was not found, then it means the external function specified a return type that doesn't exist. So we're going to throw in error. External function fun.name could not find type fun.return type name for external function fun.name. And now we need a location for that, which is kind of fucky. So what we're gonna do is we are creating a null location, and that null location is gonna look like, I'm gonna create a function for this because it's really annoying and I'm gonna need it a couple of times probably. No. Where do we put it? We put it here, because why the hell not? File range. So, what's this composed of? Line is 1, column is 1, offset is 0. And we also need the same for int, and we are good. So now we are giving back a location that is essentially the first line in the source code, which should be fine. Here we are. So let's test this real quick. Let's assume DJ's alert is actually returning a point and not a nothing. Could be something like control minus. Yeah, I think you're actually right. I think that's what I saw earlier. Yeah. That's it. So what's the going forward thing? So yeah, let's test this. I just specified a return type of point, which is not defined in my program. Couldn't find type point for external function. Okay, let's make that a little bit more. Couldn't find type blah blah for return value of external function blah blah. Control shift minus. Ah, cool. The more you know. Thanks. Okay, this seems to work. What if we specify no thingamajig? Works. Cool. So we're good. Great. So that only covers the return type, and now we need to do the exact same for all the arguments of the external function. So fun.arg type names for each arg type arg dot, oh cool, that's already the key. Arg type, could not find type for argument of external function fun name. That should do the trick as well. So let's specify a bunch of stupid non-existing types in the external function. What does it say? Could not find type nothing for argument 2 of external function chase alert. Perfect. Since only people that know what they're doing are gonna use external functions, I think it's fine for this to be this non-descriptive. Also, I think I'm dyslexic because my typo rates are immense. Look at this. This is not good. Well, if I am dyslexic, I made it far without knowing it. So cool. Now we have the external functions all set up. Actually, not quite yet. We need to assign that return type to the external function here, if we know it exists, and we need to assign that. Oh, that's not good. see. Ah, I can just push it into archetypes. Yeah. So archetypes, push archetype. So the argument names and argument types are two arrays that coexist next to each other, and the indices map to each other. Good. Okay. So now we have checked our external functions, assigned the types, and now we need to also wire up the external functions. What have we got here? Yes. So now when an external function is being done, it has been checked and validated, I can enter it into my types thing. So I can later, when I resolve function calls in the code, I can later look up those external functions by signature and type check that against the code of the user and just say the function doesn't exist if it's either not in here, which is a user specified function, or in here, which is an externally specified function. So let's go to the block of code in the type checker where we resolve a function call, and that is here. So what we first do in a function call, like js alert hello world, what we do here is we first type check the arguments, as I said earlier. Could not find type nothing for argument of external function js alert. Oh, that's not good. There's no such nothing. What the fuck are you on about, compiler? Whoever wrote that crap. Okay, could not find type for argument of argument 2. Argument 2 is not nothing. Ah. If you copy paste the thing, you're gonna die. If you copy paste the thing, you're gonna. Okay, that's better. Okay, so it cannot find function chase alert, which is because we have not, we have not fixed this up. So we assign the types to the arguments, to the expressions of that call. From that and the name that was given, we can construct the signature for this call, which happens here, and then we can look it up. If the fun type is in the functions, then we're good, but if it's not, we simply check. Okay, if it couldn't be found in the user created functions, we have a fallback, and that is we can look into the external functions. Yep. And if that is not available, then we can say cannot find function blah blah blah. It is interesting that it lets me do that. Cannot find function chase alert string. Did I push it into the external functions up here? I did not. So what does this want from me actually? This one's a compiler error, that's very helpful. Okay, that's not what we want to do. What we want to do is the function signature is the key, and the function, the external function, is the value. So we're good here. Cannot read property return type of undefined. Okay, that's good, but it now can find the function. So this is, I believe, in the code emitter, because the code emitter doesn't expect an external function when it resolves this function, but it expects a function declaration, which has all the information on it. This would be another case for refactoring, but I think I don't have time for that now. I will have to refactor the way we handle types, that is their encoding, when I add more complicated types like the records, which aren't implemented yet, or lists, or just function signatures, because I also want to have closures eventually, maybe. Let's see. Okay, let's see where we are crashing now. I like that I swallow the freaking exceptions and don't get a stack trace for that. It's really annoying. Yeah, do an exception. Yeah. Okay. In the function call, if I cast it as a function declaration, I'm not gonna have fun. So that makes sense. So previously I expected something out of this, which is a map to a type, and the type was essentially defining a function. And now it can be a type, or it can be an external function, which is not a type. So this is the case where we resolve to a user-defined function. And this is the case where we resolve to an external function. All we need to know at this point is the return type of that function, because that is used to evaluate the rest of the AST in terms of types and semantic analysis. So, long story short, I can fetch that out of the thingamajig, but now this is not fun. Signature node location, okay, fun type. What the fucking hell? Fun dot return type, which we assigned previously before we went into the full type checking. So now this shouldn't crash anymore. Now we should get a crash in the type in the code emitter. Yeah, keep doing that. Okay, let's see what's happening. Yes, awesome. As I predicted, it crapped itself in the in the code emitter. Yeah, so I think we're done for the type checker for the external functions, and now we just need to make the code emitter happy. And the way we're gonna do this is gonna be interesting. It's now 8. I think I'm gonna take another break. I want to finish this tonight, otherwise I won't get this shit done by Friday. So this is gonna be a longer stream, but I'm taking breaks, and so should you. Let's just see what needs to be done. So the emitter works as following. It gets the array of type annotated function declaration nodes. That is the main function. And the other crap. And then it builds a lookup. Arnie back? Yeah, Arnie's gonna be back. It builds a lookup for all the functions that were user defined. So I think I'm gonna just put an external function lookup here as well. Does that make sense? And then when I emit the function on a function call, I emit the code for the arguments of that call, and then I emit a call instruction. And here Yes, that's good. Here I need to make the distinction between a call to a user-defined function, that is a call that lives entirely inside the virtual machine, and the call to an external function. And I need to differentiate between a blocking and a non-blocking external function call. So yeah, I think this is gonna be easy. This is gonna be very easy. Cool, I got a plan, but I need a break. So I'm gonna put on the Arnie again. Oh, you can actually just put an image there and then disable its visibility. That's nice. Okay. Okay. Everybody sees the Arnie. I guess you see the Arnie. And I'll be right back. 10 minutes. And we're back. And now I've figured out how to fix up this thing. Let's see if we can rename it. Yes, we can. Perfect. What's an Anki card? BitEuler, we need to know what's an Anki card. Cannot read property of index. Oh, that's cool. Anki card. Let's see. Flashcards. Ah, so they reinvented flashcards and call them Anki now. Interesting. You have a test, a compiler exam. What could they ask you in a compiler exam? Write me a LR1 grammar or shit like that? So we just noticed that we get an exception in here. So let's fix this up. We will differentiate between functions defined by the user and functions defined by an external injection kind of thing. So we best push this in the emitter context, which is passed through all the emitter functions to keep track of stuff. External function lookup is a map of string to an external function. That's easy. I need to disable this. Wave. Hey Igor. Hello. We are implementing external functions, that is functions defined in JavaScript that should be callable from callable from Paperbots. You know, guys, what I don't understand? So I have this little desktop Twitch chat thing, and there's like a gazillion people in here, but this doesn't correspond at all to the number of people that Twitch reports as viewers for the stream. So who can tell me what is going on? It says 4 watching now. Oh well, weird. Anyways, external functions. I need to pass this through. External functions is a map to an external function. You are correct, Igor. Not every piece of software is bug-free, except mine, like this thing here. External functions. Good, I like this. This is coming together. Yeah, this should be the types external functions. Okay, this is being passed down. Build grammars. Draw me the LR. Oh my god. Active record. How do all kinds of data flow analysis work? How does BUM? BUPM? What's BUPM? SSA forms. Yeah. Register allocation. 400 cards with exam questions I have to learn by heart. Well, when I did compiler engineering at university, and I never finished university, regardless, I did compiler engineering as a student and then as a tutor at university. It was a lot of fun. We had an exam, but I think there was more weight placed on the practical thing. Mr. Bitcoin, you've been working on type checking. Do you store a list of function signatures somewhere? How do you check argument types? Yes, so there is this types interface, which has a map from record names to their type and function signatures to their type. And then for housekeeping purposes, I also have those two separated out into explicit maps for the two types of types. And now I added external functions, which are yet another sort of type that we need during type checking and during emission of the code. So let's see. Type check, rec. The type checking of external functions is done. Now I need to emit code. Here we go. So we emit the code for the arguments, and then we look up the function in the this is way too freaking easy. So the function is a user function or an external function. User function is a bad name. Is a function from the program, of the program, inside the program. I'm bad with this. Bottom-up pattern matching is for command selection. It selects like the best command for a whole. Okay. Plain information in the master tree goes for 80 ECTS. It's allowed to be quite a lot of work. Oh yeah, ECTS points. I haven't heard that in a very long time. I did do bachelor thesis. I did informatics and economics. It's a single degree. I never did the economics exams, so that's why I didn't finish my bachelor. Okay, so if at this point when we emit the code, we know that all the functions that have been referenced in the code of the user have actually been defined. They were either user-defined functions inside the program, or they were defined externally and injected into the compilation process as an argument. Now in the code emitter, I only have two cases. Either it's the user function or it's not. And if it's not, it's the external function. So function lookup, why is this? Yeah. So I learned a trick from Michael yesterday. So I can destructure stuff, and it doesn't work. What a surprise. Must be a very what? Let's see, we should have this somewhere else. Nope. Well, TypeScript destructuring. Yeah, it's curlies. Yep, it's curlies. Oh, yeah, that makes sense. Okay, so we know it's either a user function, and if that triggers, we just insert call instruction into the emitted code, and if it's not, we look up the external function in the external functions lookup, again based on the signature of the function call. And we know that it exists because the type checker would have told us otherwise. So then we push kind call ext, which is an external call. And the function index is gonna be okay. So we're gonna do the same trick as with normal functions. The way this works is, what's going on? Okay. So the way this works is, at the moment, if you have a function that's user-defined, once we type check this, we get all these functions, and each of these functions gets an index. The main function gets index 0, and all other functions get the next free index. When the virtual machine executes things, it has an array of these functions, and every time there's a call instruction, it fetches the index of the function that needs to be called next, and then can look up the code of that function in this array of functions. And what we're going to do is we are going to do the exact same for external functions. So all the external functions that have been injected into the compilation process will get an index. And when we emit a call to an external function, we just emit the call instruction with the index into the external functions array that the virtual machine is going to get later on. And the way we do this is, let's see. Okay, I missed the plot. There's the function call. Okay, so the way that we do this is we need a new instruction so that the virtual machine knows to look into the external functions array and not into the internal functions array, which is going to call that call ext for call external one. This is complaining, typing is not properly external function, no string index signature. Okie dokie. So the emitter context has an external function lookup. That's what we should call it. And we're gonna fix it up here. Okay, then it should complain that this doesn't have, the instruction doesn't exist yet, and the external function doesn't have an index yet, so we need to fix that up as well. So let's add the new instruction for external function calls. Where are the instructions? There are the instructions. There is the call instruction, and we're gonna add a call external instruction, and that takes a function index, and we need to add it to this union. Call external instruction, and then we will have to fix this up down here later on. So the first thing, the next thing we need to do is give those external functions an index. And I believe the best way to manage this kind of thing is to not let the user just give us an array of external functions, but to create a new class that makes managing this a little easier. Okay, so we need the functions, which is an array of external function. Okay, then we need to have an add function thing that takes the name, so essentially just this. Takes the name, the string argument types, and the return type name. And we're gonna add more to that. We're gonna also take whether it's async, that is whether the compiler, the virtual machine then has to wait for that function to return a value. And we are also gonna let the user specify the function itself. So fun is a args of any that returns an any, and that should be that. Okay, why doesn't this work? A rest parameter must be of an array type. Okay. So this is how you specify a function with variable args or var args in TypeScript. At least that's what I looked up in the break. Good, and then we need to create this external function. So all of this shit should probably become a public read-only thing, so we don't get confused when constructing our types. This should be a public mutable thing. And then we can make this into a single line, fix up the formatting. So what do we need to do here? We create a new array, we create the thing. Then we need to also store whether it's async. And we need to also store the function itself. I think this makes sense to specify all in one go. So the resulting emitted code will have all the things the compiler or the virtual machine needs to execute the code, including the external functions that the user now specifies here. So, and it also gets an index, of course, which was the whole point of this exercise. Index. Why? Oh. Okay. And then we need to construct the things inside of this thing. Do we? No, actually that's all we need here. We just need to make sure we do the right thing here. So let index equals functions plot length. Good, and then we need to construct the extern. And I guess name the archetype names, third type name, the async flag, the fun, and the index we just calculated. And we can push this into this dot functions. And then we make this private, that should be. We're also gonna add the lookup in here, so we don't need to create it ourselves. This lookup. You have to use curly braces. Yeah, oh yeah, that's an old message, okay. So then we can make this an instance of external functions. Do we export that? Yep. Then there will be a bit of complaining going on. The type checker will take external functions now. So, do we need this in here? Yeah, we need this in here. So then we have for each of these we can make this simpler because we already built the lookup. Functions lookup. Type of name. And if this is true, then we can throw the exception that that function has already been defined. So there should be another place where we need to fix things up. So for each function in the external functions, we just need to index the field. That's correct. Okay. Then, why do we use external functions? Ah. Where do the types come from? Yeah, I think we can leave it like that for the moment, even though it's a duplicate thing, imaging. So let's see if we fuck this up. JS alert. Okay. Cool. Okay. So now we have that figured out. The type checker. Does it still do the function call thing? Okay, I assume it does. Let's see. Let's break our necks. Okay. Okay. Good, that means we now have two places where we need to fix things up in the emitter, but the type checker is done. As far as this little refactoring is concerned, the external functions here become and external functions thingamajig, and the emitter context also gets an external functions. Ah, yeah, that's already good. We don't need to push all of that down there. We can just push the lookup down there. Because now our external functions have an index, and that index is what we will need to emit our new call external instruction. But first we need to fix this up here, because now we have two types of function calls. So if this is a user-defined function, we look it up here, and if not, we look called fun. From the external function lookup, we know at this point that it's either one of these, so we don't need to handle any error states. And if the called fun.return type, I can just, if there is a call, what? Cannot find name. Oh. Okay. Up here we get a complaint because the emit program doesn't get the external functions. Okay. Then we just need to fix up the shizzle. Oh, where's the emitter? The emitter is here. So are we doing the right thing here now? Yep, we fetched the external function and then we use the external function index to emit this call ext. Good. So then we added the external instruction thingy here, which is also good. And then last, the last thing we need to do is push the external functions in here into the virtual machine, which is pretty fantastic because now all that's left is to do exactly what we do here, just for an external function. So case ext is an external functions dot functions. That's a bit funky. Oh yeah. So we get the external function here. The frame takes a function. Oh fuck me. The frame should take. Ah, that's not good. So the frame can either be a function code or an external function. And the locals. I need to create a slot, but I don't have a variable declaration for that, so the slot also needs to or string, I guess. No. Still function parameter, because we're gonna be nice to ourselves and our future selves mostly. So external function. Map. Yeah, I'm mixing parameter and argument here, which is stupid, but I'm gonna clean this up in another session. So we're just gonna call this args, and this is gonna be args. So the reason I need to do this, first of all, it's nice to have a name for the argument of an external function. The second issue is for the virtual machine, it has slots. A slot is a mapping between the virtual machine and the variable in the source code. And it's nice to have some structure to that, like the slot either stores a link to a variable declaration or to a parameter, or to, in this case now, an external function parameter, which is rather nice, although I don't have to construct a frame for that. Fuck it. It's fine. It's a little bit more civilized, so we're gonna take that. Okay, let's fix it up down here. Args, arg dot name, and then that is done. Okay, and now for my final trick, let's fix this up. So if, and this is nasty, but who cares? Instance of external function, because external function is a class and not an interface like function code. We need to fill up the locals. Do I need to fill up the locals? Yes, I need to fill up the locals. Hey, Sapphire Soul. Welcome to watching Mario suck at coding. Works. Push. It's nice. Okay, I got the locals, and then frame code. Was this stupid? I have a feeling it was stupid. It was stupid, because this frame, well, I need to be able to define a frame based on an external function. Hey, I doubt that. Not the watching part though. Watch me suck at typing. Yeah, We're all good at sucking. So this instructions does not exist on external function or function code. How can I make sure that this never becomes a So I need a sort of external frame. I guess. Let's see why this is an issue. Okay, yeah, I don't need to do this. I look it up in the external functions, then why do I create a new frame? I don't need to create a new frame. And I don't need to transfer these. So let x arc be an array of the fun arc's length. So I need to transfer the values from the stack in case of an external call to this array. Okay. And then I need to call the external function. That was easy. Okay, and then I get a result back. And that result needs to go on the stack in case the function has a return type. Oh, let's smoke this. Okay, stack pop. Okay, so I'm transferring that into the array, and then I call the external function, which is referenced by that field. And if there was a return type, I need to take that result and push it onto the stack. And that is it. I think we now have external functions working, so let's see if that actually does what it's supposed to do. First we need to fix or upper this thing here. So this is a new external function parameter, and that has a name and a type, and then a return type, and then a function. So this is the message, which is a string. Okay, let's make this a little bit more civilized, I guess. So Sapphire Soul, why are you not in the Seeds of Soul chat thingy? Okay. Oh my god, I suck. Heard enough puns for today. Cool. What does this want from me? It wants a name. It wants the... oh yeah. Then we need this. Let's make it real easy. And let's remove the second one down here. Oh, yeah, that's why. And we need an external functions here. And then add our function the old-fashioned way. So we're gonna do this with JS alert. And then next it wants the arguments from us. The return type is nothing. Is it async? No. And then we just need the function which takes a thing and returns nothing. And that will just call this JavaScript alert thing. Show is in Ranger's stream. Yeah. Okay. Cool. And then we have a parameter, external function parameter, which has a name, which is message, and which has a type, which is string. Oh my god, I believe I am done. Dup, dup, dup. Dup, dup. Yep, that looks good to me. So that was a lot of coding without testing. Let's see if we get what we want. This needs to reload. Okay, cool. Length of undefined. Okay, so it seems like I've fluxered up the external functions thing. For those who joined the stream, I'm building a programming language. The programming language is going to run in your browser. It's going to be able to call into JavaScript functions. I'm currently building the bridge, the foreign function interface between that and my programming language. And that comes with a bunch of teething issues, as you can see. So I have the functions. This is not okay. Easy peasy. Anybody know if there's a hotkey for jump to type in Visual Studio Code? This is external functions, and lookup is this, and an empty map. So I require a drum roll now. Pretty please. Ha. Could not find type for argument one of external function chase alert. Okay, there's a bug, and I should get a squiggly line thingy. Yeah, let's postpone the drum roll just for like two seconds, 2 minutes. Let's try it again. Argument type. Yeah, it shouldn't be the name, it should be the type name. Me stupid. That's in the type check function. Chicken intensifies. No pressure. Okay, so go return type name, and here we need the type name. Okay, this is gonna work. I guarantee it. Sort of, kind of, I guess. Cannot find function. In the function call, external functions, the signature is JS alert, the external functions. Okay, I am fucking up building the signature somewhere. That's because I refactored without testing. Type name. Okay, I need more chicken. Please give me more chicken. Is it a chicken? Could be a chicken, I guess. It's reloading. Guys, it's reloading. It's reloading. Oh my god, it compiled. That's good. So, let's see if it runs. This is my machine code. It pushes the value hello onto the stack, then it calls the external function with the function index 0. It pops the result, although it shouldn't, because there is no... That is wrong. Well, we're gonna figure that out later. Let's see if it calls the alert method in JavaScript. And drum roll. Ha! External functions is undefined. Well, aren't you just the sweetest little thing? That was in the virtual machine. should never happen. You joined the stream at the most exciting time. This is like the last thing I'm gonna do today, making sure that this works. And I finally get to execute some code, so that's nice. Let's see what she does. She does nothing. Why? Oh. That is undefined. That is not good. So I need to get that thingamajig here. There should be, oh, there's squiggly lines. Oh no, so many squiggly lines. The module, that's the externals. I push that in, I get the result. The result is a module. The module should keep track of the external functions that were pushed in. External functions, and we are happy we get a squiggly line here, so we put the external functions in here. So we're good here. We are almost good here, because we can now fetch the module external functions, and it wants the, what does it want? What do you want? You want external functions, so that's good. And then here it says, well, it does not exist on type string identifier. What? Yeah. The code is female. No, I just suck at pronouns or articles or whatever you want to call them. The code is neutral. Until it doesn't work, then it's a motherfucker. So I fluxered up this definition here. It should not be an external function thingamajig. So this should now be good again. Yes, yes, yes. Okay. 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 So steppity step, and again, oh my god, it works. Sort of. It says message instead of hello. But hey, that's already progress. Okay, let's try it again. Tap, tap. Okay. Puppet, which makes no sense. Stop, run. Let's see again. I don't care for this. I care for the reason why there's a pop. So let's fix that. There shouldn't be a pop. And that was in the emitter that goes over statements. Oh god, I pressed the key and I don't know what happens. Okay. Get statement lists. If return type is default fun.return, we found a bug. So there should be no pop here anymore. Exactly. Steppity step, steppity step, and steppity step, and we're done. Good. So the last thing we need to do is figure out why we're not getting the hello. We make it a hello world. Why we are getting this and not the virtual machine. We pop the stacks, we push the arcs in here. This is wild. No, that's not the reason. Message is just a name. Message is just the name of the argument. Wait a minute. So I have now... Oh my god. You are actually... How the fuck do you remember that? I haven't committed the code. I haven't looked at that piece of code in a while. Are you a magician? Oh fuck yeah. 3 fucking hours of torture, but we finally got external functions working. Okay, so yeah, BitEuler is magic. You're a wizard, Harry. Oh my god, we got external functions working. I cannot believe it. This is very nice. So let's add more of these and see if we can do something fun in our programming language. JS console. Console.log takes a string. Nope, let's call it something else. Let's call it print, and it takes a number which returns nothing. And then we overload that, and that takes a boolean and returns nothing. And we overload that, and that takes a string and does nothing. So, and then we're going to check if our loops work. Print I, and I equals I plus 1. Drum roll. We're gonna need the console window for that, so we should get some output here now. So that is a lot of stuff. Okay. I mean, I'm getting stuff, but so it should print until 9. Well, there's a bunch of stuff wrong. First of all, it executed the loop 11 times instead of 10 times, which is not good. Second of all, it prints an array. It prints an array and not the thing itself, which is just a number. So yeah, BitEuler is mean. He doesn't say earlier, he just wants me to suffer and watch me hate myself. Okay, so BitEuler, why the hell is my counter broken? Let's make it a little smaller. And then let's also add a button that just executes the program until it's done. Do you want that? Yeah, I guess we want that. But first, let's figure out why the loops aren't working. Nope, stop, run. So, I push a 1, I duplicate it, I push a 0, I compare it. The comparison says, yes, this is bigger than 0 or equal to it. Then jump if false. Push a 1. So this is my loop counter. Ah, it shouldn't be bigger than 0. It shouldn't be bigger equals 0. It should be bigger 0. Yeah, that makes a lot more sense now. Okay, that's in the code emitter. For the repeat statement, yes. The code emitter for the repeat statement is where in the compiler? The repeat statement is, that's the VM. Repeat statement is here, so this is the header loop, the loop header, and here I'm doing a stupid thing. Okay, then also let's set up a button. One's called debug, and the other's called run. In case of debug, it does stepping. In case of run, it just executes. But we need to be smart about that, because if we just let the virtual machine run until it's done, first of all, it doesn't have to be done ever, because you can have infinite loops. And second of all, we would block the UI thread, because JavaScript is single threaded. So yeah, let's create a new button. And that button is debug. See if I wrote every bug. I think there is a moment I saw it. You might have found it yourself until the message reaches you. Oh, or I would have already found it. I was wrong. Yeah, it's easy being an armchair debugger. It's good though. You saved me a lot of time by telling me that. Is that what I want? What I really want? Debug step. Okay. Stop. It becomes debug again, which is good. And then we want to have a run. Debug. So, God damn you. Gonna copy that floppy again. If the VM is null, then we know we're not running yet, so we compile the module, we build the virtual machine, we set all this to and again, anyone? Yeah, backseat coding is fun. So step is disabled, debug is disabled. Oh, no, that's not what I want. I want this. I want this. Debug. Debug step should be disabled anyways, so I wanna disable. Yeah, this is pretty terrible, all things considered, but fuck it. No, that's not what I want. Debug should be disabled when I click on run, because I can run or and debug at the same time. And then I need to remove that here again. Run becomes run again. Debug is enabled. does that. Huh, it's not what I'm doing. Cool. Oh yeah, I'm rendering the VM state here. That's not what I want to do. What I want to do, what I really want, is to set up thing. Let advance equal a new function thingamajig that itself calls request animation frame. That's interesting. How can we fix this? Okay, if dvm is dead, we return immediately. That breaks that loop. Otherwise, we schedule another call to advance. And here we want to do this. So when we click stop, then dvm is set to null. So this should kill the advancement of the virtual machine. Otherwise, we do a run, and we do, I don't know, 100 instructions. And does run return anything? Nope. If vm state equals vm state dot completed, then we bail. And this does not work because the condition will always return false in the types of value, and vm state have no overlap. Oh, state, not stack. This looks good. So now this should execute this thing in a request animation frame call, 100 instructions per frame, and do the needful. So let's see if that works, because that will make my debugging life easier. So this should print 0 and then bail. Hur fucking ray. Has it stopped? So if this means that we have reset already, this means we need to reset here. Yeah, this is ghetto again. You shouldn't do state management like that. It's really terrible, but I am just a poor boy. I need no sympathy. Okay, so we run this and it's done. Cool, that was fast. I'll run it again. Run it again. Okay, the second run doesn't work, which is interesting. Let's see. Oh yeah, I should set the VM to 0 as well. And that is the great thing if you use nullable types for your state management. Pretty terrible, but it gets the thing done that we want to get done. So you should print 0, 0, 0, 0. Wonderful. You should now print 0 to 9, even though you're still printing arrays. Holy crap, it works. Amazing. And the next thing I want you to do is to print the actual fucking thing. So let's see what's up with that. So why did this work? I really wonder. Because this does not, god damn it, this does not print an array. Oh, it does print an array. Interesting. So let's see our virtual machine dispatch for the call external function. Maybe I need to call yeah, that could be it actually. Not quite it. God damn it. Fun this thing. Yeah. This is so weird. What happens if I do console.log? Yeah, it's just the thing I wanted to do. There should be something like an apply. What does this do? This is the function, this argument, blah blah. Calls the function substituting the specified object for the this value and the specified array for the arguments of the function. Cool. But calls is the same, right? Calls the method on an object, substituting an object for the current object. No, apply. Apply. Calls the function, substituting the specified object for the this value. Okay. Let's see. Ah, that didn't work. What is it you want me to do, dear TypeScript? This must be a function, but this is not a function. This is kind of sort of weird. Now it doesn't do anything again. Okay, let's ask the internet. JavaScript apply function. No, the values on a stack are just plain JavaScript objects. Like if it's a number, it's a number. If it's a boolean, it's a boolean. If it's a string, it's a string. It's just me not knowing how to properly call a function. Ah, okay. Yeah, I don't want to apply. What I want is to call that JavaScript function and have its arguments be replaced by this array of values, which is what call should do. But I'm not sure because I suck at reading documentation. Function. What? Ugh. I think this is what I want. It's just the fundamental difference accepts an argument list while apply accepts a single array of arguments. Like what? Okay, I got food, product, call, this, name, price. Yeah, that's not what I want, dude. New food. This is really grinding my gears. I also like how it doesn't execute anything now. Yeah, a list of arguments to be passed to the let's debug, because ultimately if this xargs has is an array of arrays, I'm gonna be very sad. No, it's not. Why is it double quoted? This is not the problem though. So what happens if I step into that? Message is a fucking array. Why is it an array? Oh, no. No, according to the documentation, apply will, I think, invoke the function on each element in the array, as I understand it. God damn it, load the fucking thing. So calls a function with a given this and arguments provided as an array. Syntax this. An array-like object specifying the arguments with which function should be called are null or undefined if the argument should be provided as function starting with ECMAScript. Can be a generic array-like object instead of an array. Object can call an existing function. This refers to the kernel. With apply, you can write a method once and inherit it. Apply is very similar to call. The type of arguments is supports use an arguments array instead of a list of arguments. Yeah, you're right, it should be apply. But it doesn't do the thing it should do with apply either. So that's kind of fucked up. It does what it's supposed to do with apply. Well, we have learned our lesson. Now, the other thing we have here is that these freaking curlies, those quotes shouldn't be in here. So that must go away as well. And we are gonna, we're gonna fix that up in the grammar, I guess. Grammar packjs string. Stringify. Oh, this is stupid. Okay, now equals substring of value.length. This should be what I want. Okay. Yeah, let's just do this one time. Yeah, that looks good. Does it bork itself if the string is 0 length? Nope, doesn't bork itself, so we didn't fuck that up. So the repeat works. Let's see if we have the while down. While I is smaller than 5, do print I equals I plus 1. And yep, that seems to work. If true, then print true. Else print false. Print. Cool. cool. Then let's do an infinite loop that breaks if I is bigger than 4, then break it. Okay. Perfect. So, who has a Fibonacci implementation that I can steal? Fibonacci algorithm. I would say let's steal the one from Lua. Ah, that's not good. Is it? I guess. God damn it, I'm so lazy, I can't think straight anymore. Oh, the Python one will probably work just fine, because it's also similar. Yep, let's take that. So fun fib takes a number. That's not good. Then function fib now must not return a value. Of course it must. Print fib 1. That looks good. Wait, the Fibonacci number of 2 is not 1, is it? I don't know. I don't know anymore. 10. Wow, that took a while. Let's write this in JavaScript real quick. Fib is if n is more than 2. Oh my god. So cool. It's stupidly slow. Although we could probably just rake up the number of iterations per frame. I mean, 100 instructions per frame is not a lot. So let's make it 1,000 instructions per frame. Yeah, that's almost instantaneous, so that's good. Interesting. I wonder how many instructions that are that's actually fib10. Shouldn't be that many though. So yeah, the interpreter is probably fast enough for our purposes, which is moving this little robot around. And again, I need to support asynchronous methods, which I think I'm gonna postpone until tomorrow. We managed to do a lot of things today. We refactored a bunch of shit and then we added external functions, and I think the way we can add external functions to the whole compiler or rather to a virtual machine is pretty okay. I mean, this is not the nicest format, but that's just me being shit at formatting code, but it's very easy to create functions this way. Like I can totally create a bunch of, like my standard library. I can now create a standard library, which is very nice because at the moment I cannot combine numbers and strings. So this returns a string and value. Okay. So I can now do toString. And hope it works. Yes, it works pretty well. I like this. Yeah, it's pretty cool. It's also pretty cool if I can just step through the fucking virtual machine, so that's nice. Oh, that's actually cool. I saw that it just converted the... That's really cool. So I have a push of the number, which gets on a stack, then I call the external function, which returns it as a string, which pushes it back on a stack, then I call the print, and it gets output here, and then my thing is done. Oh my god, this is so fucking great. Yeah, I think we can be proud of ourselves. This is day number, what, 3? Yeah, day 3 working on this bullshit. From the type checker to a running virtual machine with low-level debugging and external function calls. So tomorrow I'm gonna implement asynchronous function calls, external function calls, so we can actually write, yay! We can actually write like synchronous code here, and the thing will, yeah, no, I'm not gonna manually step through that, but you can. I'm gonna push this now. So let's see what we did. We added external functions. Is that all? Pretty much all. And we made the debugger prettier. Git commit added external functions, added run button to execute this script until it's stopped. Is this actually true? Like, I don't even know if this works. So let's see. While true, do print hello and run. Yeah, that's a lot of things it does. Stop. Cool. This works. Pretty good. Did I freeze the thing? No. Is it still executing? That would be fun. Let's see. I think I just broke Chrome. Ah, debugger paused. Oh, it's still in the advance. It still executes actually. What's the VM state? State is 0. I don't know what 0 is, so state is 1. Completed. Okay. Step into the function call. What? Why would it stop here? Oh. Break. I have a feeling I fucked up some references. Let's see. Yeah. We shouldn't do that. Let's not assign it to a local. Because we captured the local and not the field. So when we set the field, nothing works. Okay, it reloaded. If I do this, nothing should happen. Okay, good. Well, almost nothing should happen because of course something always happens. Okay, stop. Yeah, we're good. Okay. Very nice. Very, very nice. Okay, so tomorrow asynchronous external functions, which shouldn't be a big deal. Because why is it not a big deal? Yeah, because all I need to do in the virtual machine is actually let's see. All I need to do in a virtual machine here is check if it's asynchronous, and then have a little state flag in my virtual machine that says, oh, as long as that function doesn't, so I get a promise from that function. Asynchronous functions need to return a promise. And then I just bail out of my interpreter loop. And in the next call to run of the interpreter, I just check the promise if it's completed or not. And if it's completed, I can continue with my execution. If it's not completed, I immediately bail out of the interpreter again, giving the external asynchronous function time to execute whatever it wants to execute. So this is fucking fantastic. With the external functions, I can also easily wrap more computationally expensive stuff inside JavaScript, which gets JIT compiled. So writing a small game with this should be more than fast enough, unless you want to have like 20,000 particles of shit. With the asynchronous functions, I can finally make a program like this work. Oh yeah, what happens if we do this? This would be interesting. I'm not gonna wire this up now, I'm sorry, I'm too tired. Anyways, I'm really happy that there's still some people joining the stream, even though it's getting more boring and boring. But I'm on a timeline, I need to get this whole thing done by Friday. Of course we want 20,000 particles, who doesn't? But then you should write a GPU particle system and not do it on the CPU. So anyways, thanks for joining. It would be cool if we had more interactions. I know the topic is probably too dry for most people, except for the ones that are learning for a compiler exam. Quick, BitOiler, what are the forms? How can you generate SSA from... anyways, I'm gonna quit for tonight. I'm gonna continue tomorrow, which will be Wednesday, when we fix up the asynchronous external function calls, and then write the final debugger to be used here, not just a low-level one. And I think I can get this done by Friday, which is pretty fucking fantastic. Cool. So, have a good night, or good morning, or good afternoon, whatever it is on your time zone, and see ya. Bye.